The next type of trigonometric integral that we're going to be looking at is the one that has a power of cosine that is odd and positive. So this one is going to be a little bit different. However, the process will be the same. We're going to save out one cosine that will eventually make up my du. We're going to convert the rest to sine, expand, and integrate. So an example that we could look at for this one might be something like odd and positive cosine. So cosine to the fifth of x sine squared of x dx. So again, the power of cosine is odd and positive. Now if we look up at the problem we just did, notice the power of cosine up here was even, so this process would not have been applicable to this type of problem. So the directions are to the first step, save one cosine. And of course, we know that this one cosine is going to make up our du eventually. So save one cosine. So that will leave me with cosine to the fourth of x, sine squared of x, cosine of x dx. This is the cosine that I saved out. Second step is convert the rest to sine. We're going to convert the rest to sine by using a Pythagorean identity as well. And the Pythagorean identity that we want to use here is the Pythagorean identity. So we're going to take cosine to the fourth, and we're going to think, okay, cosine to the fourth, that's the same as cosine squared, and this is kind of a funny way to write this, squared, sine squared of x, cosine of x dx. So again, we know from our Pythagorean identity that cosine squared is equal to 1 minus sine squared. And I'm squaring that. And of course this was possible because of the Pythagorean identity, sine squared of x plus cosine squared of x equals 1. Would not have been possible otherwise. Okay, then our third step, if we look back up, is to expand and integrate. Now the way that we're going to expand is to distribute through. So let's look at the expansion here. Now when we expand, what ends up happening is we take this 1 minus sine squared of x and we actually FOIL it out, first, outside, insides, and last, and then we're going to do that before we distribute. So when I expand this, I end up with 1 minus 2 sine squared of x plus sine to the fourth of x for this expansion. And again, I'm squaring a binomial. I can't just distribute the squared. I need to actually first, outside, inside, last. And then I have my sine squared of x, cosine of x dx. Now what we'll do is we'll take this piece right here and we'll distribute it to each of the three terms here. So this expansion takes a little bit longer. So when I distribute through the 1, I end up with sine squared of x, cosine of x dx. Okay, minus 2, and I'm going to just set up these integrals right now. Sine to the fourth of x, cosine of x dx, plus integral sine to the sixth of x, cosine of x dx. And again, that's distributing through. Now, each of these is a nice little u substitution, and that's my fourth step, is to actually integrate this. Now this one's a little bit nicer. I don't even have to compensate for that missing negative like I had in my last problem. So for each of these, u is sine, du is cosine. U is sine of x dx, du is cosine of x dx. So let's go ahead and rewrite this and integrate it. When we make the u substitution, I end up with the integral of u squared du minus 2, and I pulled the 2 out front, integral u to the fourth du plus u to the sixth du. And of course, using our good old add 1 divide by the sum, u cubed over 3 minus 2/5 u to the fifth plus u to the seventh over 7. Now, again, I want to simplify this. I could substitute in right now for what u was, and u was sine, or I could simplify it in terms of u and then substitute in, and that's what I'm going to do here. So our first step is probably to find a common denominator. The common denominator, when you look at 3, 5, and 7, they're all prime numbers, so the common denominator is going to be the product of those numbers, 3, 5, and 7. And I can see that this first term is missing the 5 and the 7, So I'll have 5 times 7u cubed minus 2. This denominator piece is missing the 3 and the 7, so I'll multiply the top by 3 times 7. This last piece is missing the 3 times the 5 because it already has a denominator of 7. So here's my common denominator of 357. 3 times 5 times 7, which is 105, but for now I'm just going to leave it like that in case I can cancel something. Now looking up into the numerator, it doesn't look like I have a common factor in terms of a coefficient, but I do have a u cubed, so I do have a variable component I should be able to pull out. So I'm going to go ahead and pull out the common denominator here of 105. So I'll have u cubed over 105 factored out, and that will leave me with 7 times 5 is 35 minus, here I'm factoring u cubed away, so I'm left with u squared. So 2 times 3 is 6, times 7 is 42, so minus 42 u squared plus 15 u to the 4th. So it's a little bit easier to simplify when I'm still in terms of my u, and of course I need to substitute back in. U in this particular case, let's scroll up and take a look, was sine of x. So I have sine cubed of x over 105 times, and usually we like our highest powers to go first, so I have 15 sine to the 4th of x minus 42 sine squared of x plus 35 plus c, my constant of integration. And that's my solution. And again, you really should practice simplifying these because we're going to want to be able to simplify, plus it gives us a good chance to practice our algebra.